Hi everyone and welcome back to another lab. Today we are going to cover and verify OSPF protocol, and specifically we will cover the OSPF adjacencies between different routers. So by the end of this video you will be able to understand how to configure OSPF v2 on Cisco routers. You will also implement OSPF using two different configuration methods. The first one is directly under the router configuration mode and the second one is under the interface configuration mode. You will also be able to establish OSPF adjacencies between multiple routers and verify OSPF neighbor relationships using essential commands. You will also configure a router on a stick to enable VLAN-based LAN networks. And finally, you will be able to perform connectivity tests to ensure successful OSPF routing between devices. So as usual, I'll start with a quick introduction to OSPF version 2. I'll go through the what, why, and hows, and then I'll go through the lab topology, then the lab objectives, and then after that, I'm going to cover the lab tasks, and then finally, walk you through the lab solution. So OSPF v2 stands for Open Shortest Path First. Version 2 is a dynamic routing protocol used in IP network for routing IPv4 traffic, and it is an interior gateway protocol, or IGP, meaning it is primarily designed for routing within a single autonomous system, such as a large enterprise or organization's internal network. OSPF is a link state routing protocol, which means that it builds a complete map of the network topology using the concept of areas. Each router in an OSPF network exchange information within its neighbors, building a database that allows it to determine the best path to each destination based on the shortest path algorithm, often referred to as the Dijkstra algorithm. A key feature of OSPF is its ability to divide a large network into smaller, manageable sections called areas. The most important area is Area 0, and it is also known as the backbone area, which is used to connect different areas within the network. So you need to understand that OSPF routers send link state advertisements, or LSAs, to inform other routers of change in the network, such as link failures or new paths have been introduced to the network. These LSAs ensure that all routers in the OSPF domain have a synchronized view of the network topology, which allows for efficient routing decisions. It also supports route summarization, which reduces the size of the routing table by grouping multiple networks into a single route. So OSPF uses a hierarchical design with areas to limit the scope of LSAs and minimize the amount of routing information shared across the network. OSPF uses cost as its metric to determine the best path to a destination, with lower cost routes being preferred. The cost is typically associated with the bandwidth of the link, meaning that faster links will have a lower cost and be preferred in the routing process. OSPF is also a classless protocol, which means it supports variable length subnet masking. One last thing about OSPF is security, and it supports authentication, ensuring that routing updates come from trusted sources and can be configured to use either clear text or MD5 authentication to protect against unauthorized routing information from being injected into the network. Okay, so how are the OSPF adjacencies established? So this process occurs in several stages, from initial discovery to full adjacency, and each step ensures that routers can communicate and share their view of the network topology. The process begins with the exchange of hello packets, which are sent periodically by each OSPF router on all OSPF-enabled interfaces. These hello packets contain essential information such as the router's OSPF ID, hello and dead intervals, and the OSPF area to which the router belongs. If two routers share the same parameters such as matching hello intervals, area IDs, and authentication settings, they will recognize each other as potential neighbors and transition to the two-way state. In this state, they acknowledge each other's presence but have not yet exchanged routing information. Next, OSPF routers decide whether to form a full adjacency, which is necessary for exchanging routing information. This decision depends on the network type. So on point-to-point links, such as direct connections between two routers, all routers form full adjacencies. On multi-access networks like Ethernet, for example, a designated router or DR and a backup designated router or BDR are elected to minimize the amount of routing traffic. Only the DR and the BDR form full adjacency with all other routers, while the rest of the routers form partial adjacencies with the DR and PDR. This way, we reduce the overall number of OSPF adjacencies. We will cover this in the upcoming videos. Once the decision to form full adjacencies is made, routers transition into the X-start state, where they negotiate who will initiate the database exchange, and this is determined by comparing router IDs, with the router having the higher router ID becoming the master and initiating the exchange process. Routers then enter the exchange state, where the exchange database description or DBD packets that contain summaries of the LSAs in their link state database. After the DBD packets are exchanged, routers enter the loading state, during which they request any missing LSAs from their neighbors using the link state request or LSR packets. These requests ensure that both routers have identical link state database. The neighbors respond to these requests with link state update or LSU packets, which contain the full details of the requested LSAs. Once all LSAs have been exchanged and acknowledged, the router have synchronized their database. Finally, the routers transition to the full stage, which signifies that full adjacency has been established. At this point, both routers have identical link state database and can start calculating the shortest path using the Dijkstra shortest path first algorithm. These paths are then installed into the routing table, enabling efficient forwarding of traffic between routers. Throughout this process, OSPF adjacencies are maintained by sending periodic hello packets, ensuring that neighbor relationships remains active. And if a router stops receiving hello packets from a neighbor within the dead interval, it will then consider the neighbor down, triggering OSPF to reconverge and update the routing information accordingly. So with that being said, let's move into the lab topology. And as you can see on the screen, we have 3 routers that will be used to connect multiple departments. So router 1 is connected to switch 1 as well as router 3. Switch 1 is connected to a couple of PCs, with each PC resides in different VLAN. PC1 is part of VLAN 10, which is designated for the HR department, and PC2 is part of VLAN 20, and it is assigned to the IT department. Router 3 is connected to router 1 via gig Ethernet 0/0/0 and is also connected to router 2 via gig Ethernet 0/1/0. So router 2 in turn is connected to switch 2, and switch 2 is also connected to PC3 and PC4. So PC3 belongs to VLAN 30, that is designated for the Ops department, and PC4 belongs to VLAN 40 and assigned to the Sales department. All routers, as you can see on the screen, will belong to OSPF Area 0, which is also the backbone area, and should advertise all known networks as well. So the topology is fairly simple and straightforward. And just to let you know that all end hosts and devices in this lab are pre-configured with the appropriate IP address settings and are ready to go. Finally, the objectives of this lab is to configure OSPFv2 on multiple routers within a single OSPF area and establish and verify OSPF neighbor adjacencies. We will also need to make sure that there is connectivity across all end hosts by the end of this lab. So for instance, PC1 should be able to ping PC2 and PC3 as well as PC4. So regarding the lab tasks, we will start by configuring VLANs across both switches. Then we will configure all access ports that are connected to the end devices. And then after that, we will move into step number 3, 4, and 5, where we are going to configure the WAN interfaces with basic IP address configurations and interface description. We will also configure loopback interfaces across all routers. Next, we will go to step 6, where we are going to configure a router on a stick by creating multiple sub-interfaces for each VLAN on router 2 and router 1. And then we will perform some connectivity tests locally for each department. We will then go to step 9, 10, and 11, where we are going to configure OSPF version 2, but we will follow the steps as predefined. Then we have step 12, 13, and 14, where we are going to do some post checks and examine the routing table and the OSPF neighbor table and perform connectivity tests between each department. Finally, we're going to go ahead and save the configuration, and that will be the end of the lab. Okay, so this is the moment where I normally ask you to pause the video and try this yourself to test your knowledge and skills. I have added the lab document in the video description as usual, so you can go download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. So enough of that, and let's dive into the lab solution. Okay, so I'm going to tackle the first task, and the first task is all about configuring VLANs across both switches. So I'm going to jump into switch 1, and I will go to global config, and from there I'm going to create VLAN 10, and I'm going to name that VLAN HR_department, and then I'll create VLAN 20, and then I'm going to name this VLAN the IT department. Now that we've done that, let's just perform quick post checks. So I'm going to say show VLAN brief, and you can see that these two VLANs have been created successfully. I'm going to jump into switch 2 and do the same thing. Go to global config, and from there I'm going to create VLAN 30, and I'm going to name that VLAN ops_department. I'm also going to create VLAN 40, and I'm going to name that VLAN sales department. So you can see that these two VLANs have been created, and also with the appropriate name as well. Next, I'm going to move to the next step, which is step number 2. And step number 2 is about configuring all access ports. So I will go back to switch 1, and I will configure fast Ethernet 01. So I'm going to say interface fast Ethernet 0/1. Let's the description. I'm going to say link to PC1. And then let's assign the interface to access mode statically. So I'm going to say switch port mode access, and then I'm going to assign the appropriate VLAN for that interface. So I'm going to say switch port access VLAN 10. I will then hit the exit command, and then from there I'll go to fast Ethernet 0/2. I'll then set the description to link to PC2. I will up arrow that to get to the switch port mode access command, and then I will assign the appropriate VLAN for that interface. So now that we've done this, I can then hit end, and let's just perform some in-flight checks. So I'm going to say show VLAN brief, and this time you can see that both interfaces have been assigned to the appropriate VLAN. And if I say show interface or interfaces status, you can see that these two interfaces are part of VLAN 10 and 20. The current status is connected, and you've got the interface description is configured accordingly as well. Let's do the same thing on switch 2 quickly. Now that we've done that, let's just verify this quickly, and you can see that fast Ethernet 01 is part of VLAN 30, and fast Ethernet 02 is a member of VLAN 40. And just for the sake of it, let's just issue the show interfaces status. These two interfaces are configured accordingly. So now that we've done that, let's go back to switch 1 and configure gig Ethernet 01, which is the link that connects to router 1. And we're going to configure that interface to operate in trunk mode. So I will do that quickly. I'll go to global config again, and from there I'm going to say interface gig Ethernet 0/1. I'm going to set the description to link to R1. And that interface is going to operate as trunk. So I'm going to say switch port mode trunk. We are also requested to allow only VLAN 10 and 20 through that trunk interface. So I'm going to say switch port trunk allowed VLAN 10 and 20. I'm going to end this and I'm going to just perform some in-flight checks. I'm going to say show running-config pipe section, and I'm going to say 0/1, and I'm going to include the $sign. And you can see that this is the current configuration under that interface. If I were to issue the show interfaces trunk, we are not going to get any information since the actual interface is actually admin down from the other side. So we need to enable that interface from the router's side. If I say show IP interface brief, you can see that gig Ethernet 01 is actually down. If I say show interfaces status, you can see that we've configured this interface as a trunk. And if I say show interfaces trunk, we are not going to get any information, as you can see here, since the interface is not operating. So I'm going to do the same thing on switch 2 quickly. So I'm going to go to switch 2. And from there, I'm going to say configure terminal. I'm going to say gig Ethernet 0/1. Let's set the description. So it's going to be link to R2. So again, if I issue the show interfaces trunk, we are not going to get any information. And if I issue show interface status, you can see that this interface is actually a trunk interface and currently is not connected. And you can see this is the interface description. And we will do some verification or further verification once we enabled the interface from the router's side. Okay, so at this point, we can move into step number 3, and we're going to jump into router 3 to perform some basic IPv4 configurations for gig Ethernet 0/0/0 and gig Ethernet 0/1/0. So let's go back to my topology and go to router 3. And from there, I should be able to go to global config, and I'm going to say interface gig Ethernet 0/0/0. Let's set the description, and this link is connected. Link to, let's say just link to R1. I'm going to set the IP address to 10.1.3.2, and the subnet mask is going to be /30, which is 255.255.255.252. And we will also need to enable the interface since it is admin down by default. And then I'm going to up arrow that multiple times to get to the interface ID, and I'm going to change the 0 to 1. I will also get the description command, and I'll change the R1 to R2. And then let's configure the IPv4 address. So I'm going to say IP address space 10.2.3.2 /30. And also I need to enable the interface. So I'm going to hit end, and let's just do some in-flight checks. So I'm going to say show IP interface brief. And right now you can see that we've configured these two interfaces with the appropriate configurations or IPv4 address settings. Next, we need to configure the loopback interface. So I will go back to global config, and I'm going to say interface loopback 0. And I'm going to set the IP address with 3.3.3.3. And the subnet mask is /32, which is 255.255.255.255. And let's reissue the show IP interface brief command. And you can see that loopback 0 is being configured and right now is in the up state. Now let's move into step number 4, where we're gonna jump back to router 1 and configure interface gig Ethernet 0/0/0. So I will go to my topology and I will click on router 1, and then I will go to global config, and then I will set the interface ID gig Ethernet 0/0/0. I will set the description first. I'm going to say link to router 3 or R3, and then I will put the IP address command, and I will set the IP address with 10.1.3.1, 255.255.255.252, and I'm going to enable the interface. And also I'm going to just make sure that there is connectivity between both ends. So I'm going to ping the other side of the link. So I'm going to say do ping 10.1.3.2, and we get successful ping, which is good. And if I end this and issue the show IP interface brief, you can see that the current status for gig Ethernet 0/0/0 is up. Now we also need to configure a loopback 0. So I'm going to say configure terminal and then interface loopback 0. And then I will set the IP address with 1.1.1.1/32. And if I issue the show IP interface brief, you can see that the current loopback 0 interface has been configured with 1.1.1.1, and it is in the up state. Next, we're going to move to step number 5, where we need to go to router 2 and do the same thing for interface gig Ethernet 0/1/0. So I'll go back to my topology and I'll go to router 2. And I'll say interface gig Ethernet 0/1/0. I'll set the description to link to R3. Let's configure the IP address with 10.2.3.1. And also we need to enable the interface as well. In the meantime, let's configure the loopback interface. So I'm going to say interface loopback 0. And I will set the IP address with 2.2.2.2. And then I will issue the show IP interface brief. And you can see that gig Ethernet 0/1/0 is configured with the IP address of 10.2.3.1, and it's in the up state. The loopback interface is configured with 2.2.2.2, and also is in the up state. So if I were to ping router's 3 interface, the other side of the link of gig Ethernet 0/1/0 on router 3, so I would say ping 10.3.2.3.1, actually .2, and we have successful ping. Okay, so with that being done, we can then move to step number 6, where we're gonna need to configure a router on a stick on router 1 and router 2, where we're gonna create sub-interfaces for VLAN 10 and VLAN 20 on router 1, and create sub-interfaces on router 2 for VLAN 30 and VLAN 40. So let's do that quickly. So I'm going to say interface gig Ethernet 0/1. I will set the description first. I'm going to say link to switch 1. And then also it is very important to enable the interface. And then I'm going to up arrow that to get to the interface ID command. And I'm going to say .10. And I'm going to issue the description command to say link to switch 1, and going to include the HR department. I'm going to say encapsulation .1Q10, and I will set the IP address with 192.168.10.254. And the subnet mask is /24, which is 255.255.0. I will up arrow that to get to this interface ID command, and I'm going to change the 10 to 20. I will up arrow this, and I'll change the HR department to IT department. Then I will configure the encapsulation.1q with 20, and also I will set the IPv4 address with IP address 192.168.20.254, and again the subnet mask is going to be /24. So I'm going to say end, and then I'm going to issue the show IP interface brief. And you can see that we have added these two sub interfaces. So interface gig ethernet 0/1.10, that is the gateway for PC1. And this interface, gig ethernet 0/1.20, that will be the gateway for PC2. So I'm going to jump into router 2 and do the same thing. I'll set the description with link to switch 2. I will enable the interface. And then I'll create the first sub interface. And I'm going to also configure the description for that sub interface with ops department. I'll do the same thing for VLAN 40. Now that we have done the basic configurations across all our routers, what we can do, I can verify this configuration. So I'm going to say show IP interface brief. And you can see that these two interfaces have been added. Again, gig ethernet 0/1.30, that's the gateway for PC3. And gig ethernet 0/1.40 is the gateway for PC4. So what we can do, we can actually look at the routing table at this stage. So if I say show IP route, you can see from the routing table, these are the all local interfaces that have been configured on the router. And at this point, we can jump into step 7, where we can initiate some pings between PC1 and PC2, as well as PC3 to PC4. So I'll go back to my topology and go to PC1, go to desktop, and from there, let's just reveal the current IPv4 settings. You can see this is the local IPv4 address, and that's the gateway. So if I try to ping PC2 from here, so I'm going to say ping 192.168.20.1, I should be able to ping that PC. And as you can see, we have successful ping. So I'm going to go back to my topology and I'll go to PC3. Great, we also have connectivity between PC3 and PC4. And now we can move to step number 8, where we need to initiate a ping from PC1 to PC3. Let's just do that quickly. So here I'm going to say ping 192.168.30.1. And as you can see, the ping has failed. And the reason being is because router 1 doesn't have a clue how to get to that particular destination, because it doesn't even exist in the routing table. So let's move into step number 9, where we're going to jump into router 1 and start performing some OSPF configurations. So the first task that I need to tackle on router 1 is create an OSPF ID of 1. So I'm going to go to global config and I'm going to say router OSPF1. So we can then exit from the router OSPF configuration mode. Okay, so what I'm going to do next, I'm going to go to interface config mode, and I will try to configure OSPF under that interface in order for us to enable the interface in question. And we're going to jump into gig Ethernet 0/0/0 as well as loopback 0. So basically we are enabling these two interfaces to participate in the OSPF protocol. So I will say interface gig Ethernet 0/0/0. And in order for us to enable OSPF under that interface, we would need to say IP OSPF, and then we need to specify the OSPF ID, which what we just created. If I delete this and question mark that, you would see what you can do here. These are the content sensitive help. And the first option, it does tell you that you need to include the process ID. So I'm going to say 1. And if I question mark that, it will then ask you to set the area. And we're going to say area 0. Next, I will do the same thing for interface loopback 0. So I will up arrow that. And I will say loopback 0. And I will up arrow this, and I'll just issue the same command. And then I will hit end. And let's just do some in-flight checks. So I'm going to say show run section back 0. And you can see that we have configured OSPF under that interface. And if I also issue the show run -config command section router, and you can see that the router OSPF ID has been configured, and that's the only configuration that you can see under the router OSPF1. Let's also verify that the gig Ethernet 0/0/0 is also configured with OSPF. So I'm going to say show run section 0/0/0. And you can see that OSPF has been enabled under that interface. Right now, if I wanted to see if OSPF has been formed or not, I can confirm that it hasn't because we haven't configured the other side of the link. And if I say show IP OSPF neighbor, you get nothing, or there is no output in here. And the reason being is because we haven't enabled the OSPF from the other side of the link. So we would need to do that next. So I'm going to jump into router 3. And from there, so what I'm going to do, I'm going to create an OSPF ID of 3. So I would say router OSPF. And then if you question mark that, you can just set any ID between 1 to 65,000 plus. So I would say 3. And then if we wait for a few seconds, nothing will happen because we haven't really enabled any interface to use OSPF. I'm going to exit the router OSPF configuration mode, and I will go to interface loopback 0, and I will enable the OSPF under that interface. So I'm going to say IP OSPF, and then I would say 3. Let's set the area to 0. And then let's wait 30 to 60 seconds and check if router 1 and router 3 will establish OSPF adjacency. Okay, so it has been 30 seconds so far and nothing happened yet. If I say do show IP OSPF neighbor, nothing in there. And the reason being is because each router must have interfaces configured in the same OSPF area and network space. So basically we need to configure gig Ethernet 0/0/0 on router 3 so that it forms OSPF adjacency between router 3 and router 1. So let's do that. So I'm going to say interface gig Ethernet 0/0/0, and then I'm going to say IP OSPF 3, and I'm going to say area 0. And as you can see from the output, you can see that gig Ethernet 0/0/0 has formed a neighbor with 1.1.1.1, which is the OSPF ID for router 1. So I'm going to do the same thing, but for interface gig Ethernet 0/1/0. And again, nothing will happen at this point because we need to configure router to end as well. So if I hit end at this point, and if, let's say, if I want to look at the neighbor table from router 3 perspective, so I can say show IP OSPF neighbor, and you can see that we have only one neighbor at the moment, and that neighbor has an ID of 1.1.1.1. Remember, this is the loopback interface for router 1 that we configured. You can see this is the priority and is set to 1. The current state is full, which is what we want and what we expect anyway. The current state also is for that router is the DR. This is the designated router. And these are just the did timer and the IP address that is configured under that interface, which is 10.1.3.1. This is the router 1 IP address that is configured under this interface, gig ethernet 0/0/0. So next we're gonna jump into router 2 and do the same thing. So I will go to router 2, and then I will, first of all, I would need to create a OSPF process ID of 2. So I'm gonna say router OSPF2, and then I'm gonna exit, and then I'll go to interface gig ethernet 0/1/0, and then I'll say IP OSPF2. I'm going to set the area with 0, and then I will up arrow this to get to the interface ID, and I would say loop back 0. I will also enable the OSPF under that interface, and as you can see, we have received the same message that we saw from router 3 perspective, and it does tell us that gig ethernet 0/1/0 has formed a neighbor relationship or adjacency with 3.3.3.3, which is the router 3 ID, and you can see it went from loading to full, which is what we want to see. So if I end this and then issue the show IP OSPF neighbor, you can see that router 2 is neighboring with router 3, and router 3 has an ID of 3.3.3.3. Again, the priority is set to 1. The current state is full, which is what we want. And this router is the designated router. The current address for the neighboring device is 10.2.3.2 that is associated with gig ethernet 0/1/0. Okay, so what I'm going to do next, I'm going to jump back to router 1 and I will check the OSPF neighbor relationship. So I'm going to say show IP OSPF neighbor, and you can see that router 1 is a neighbor with router 3. Router 3 ID again is 3.3.3.3. The current priority is set to 1, and the current state is full, and this router is the BDR or the backup designated router. And it has an IP address of 10.1.3.2 on that interface, gig ethernet 0/0/0. If I issue the show IP root command, you can see that we have learned new networks. So we have learned this network, and that network we can reach it via gig ethernet 0/0/0, which is the loopback interface for router 2. We also learned that router 3 has a loop interface or loopback interface that has the 3.3.3.3 network. And in order for us to reach that network, we would need to use that gig ethernet interface, gig ethernet 0/0/0 interface. And also we've learned about that network, which is the link between router 2 and router 3. So basically, if we wanted to ping router 2 IP address or loopback interface, we can say ping 2.2.2.2, and we should have successful ping. We can also ping the router 2 interface that is connected to router 1. So if I say ping 10.2.3.1, we can also reach router 2 interface, gig ethernet 0/1/0. So next, let's jump into step 10, And step 10 is asking us to perform a ping between PC1 and PC3. So I'm going to do that next. As you can see on the screen, the ping have failed, and the reason being is because router 1 still doesn't know how to reach the 192.168.30.1 network, despite the OSPF adjacency between all three routers. So basically, we need to include the lab networks as well to participate in the OSPF protocol. So that's what we're going to do next. So I will jump back to router 1. And by the way, this is step 11, and I'm going to go back to global config, and this time I'm going to configure the network under the router OSPF configuration mode. So I'm going to say router OSPF1, and then I would need to include the word network, and from there I'm going to say 192.168.10.0, because that's the network address for PC1 or VLAN 10. And then we would need to include the wildcard. And the wildcard basically is the opposite of the subnet mask. So if the subnet mask is 255.255.255.0, the wildcard would be completely the opposite. So it's going to be 0.0.0.255. So we're going to say that. And then we also need to set the area. So I'm going to say area 0. Next, we would need to do the same thing for the second network, which is associated to the IT department, which is VLAN 20. So I'm going to up arrow this, and I'm going to change the network address to 192.168.20.0, and the wildcard is going to be the same, 0.0.0.255, and it's going to be in area 0. I'm going to hit end. And at this point, we have configured router 1. So router 1 would advertise these two routes to router 2 and router 3. So router 2 will be able to know and learn about the IT department and the HR department. However, if we try to ping from PC3 to PC1, the ping will still fail. And the reason being is because router 1 still doesn't know how to get to router 2. So basically, we need to do the same thing on router 2 to advertise the ops department network and the sales department network. So I'm going to go to my topology, and I will go to PC3, and I will try to ping PC1. So I'm going to say ping 192.168.10.1. As you can see, the ping has failed. So let's tackle that next. So I'm going to go to router 2, and I would go to global config, and I would say router OSPF2. And then I'm going to include the LAN network. So I'm going to say network 192.168.30.0. And the wildcard is going to be 0.0.0.255, and is going to be in area 0. Let's up arrow that and change the network to 192.168.40.0. So now that we've done that, if I were to issue the command that will reveal the routing table, so I'm going to say show IP route, you can see that we have learned about these two networks. So 192.168.10.0 as well as 192.168.20.0. And these two networks, in order for us to reach them, we would have to use the next hop address of 10.2.3.2, which is via gig Ethernet 0/1/0, which is the link that connects to router 3. If I go back to router 1, and let's do the same thing. So I'm going to say show IP route. You can see that these two networks have been injected into the routing table. So in order for me to reach these two networks, I would have to use the next hop address of 10.1.3.2, which is via gig Ethernet 0/0/0. So now if I go back to my PC1, and try to ping this again, the ping is successful, as you can see on the screen. And if I were to jump back to PC3, and repeat that command or repeat the same test, we get successful connectivity. So at this point, you should have connectivity and reachability between all computers or all end hosts. So PC1 should be able to reach PC2 as well as PC3 and PC4 and vice versa. So that's it folks for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.